Objectives of today's lecture are that we are going to study the chemistry of some important transition elements, and today we are going to cover the chemical reactions of iron. Students, let us start studying the chemistry of some important transition elements. And the most important transition elements of first outer transition series are vanadium, chromium, manganese, iron and copper. Today we are going to discuss the chemistry of iron and copper. Students, first of all we are going to discuss iron. Iron is having an atomic number of 26. It belongs to the first 3D transition series and it is having the valence shell electronic configuration of 3d64s2. Now students, iron exists in two common oxidation states which are +2 and +3. Fe plus 2 is called ferrous ion and Fe plus 3 is called ferric ion. In the aqueous solution, iron readily oxidizes from Fe plus 2 ions to Fe plus 3 ions by the loss of a single electron. So students, iron Fe plus 2 ions, it acts as a reducing agent. Itself it gets oxidized by the loss of an electron and converts into Fe plus 3 ions. Now the electron that is lost can be gained by any other species. Therefore it is going to get reduced. So Fe plus 2 ions act as reducing agents because itself it oxidize and reduce the any agent with which the reaction is going to take place. Now students, the concentration of Fe plus 3 ions in the solution, it can be determined by titration with oxidizing agents. The oxidizing agents are going to take up electrons. Itself they are going to get reduced and oxidize Fe plus 2. Therefore, we can calculate how many electrons are taken up by the oxidizing agent through the calculations or data that will be obtained from titration. So in this way, we can calculate the concentration of Fe plus 3 ions in the solution. Now students, let us study the catalytic properties of iron. Iron as a catalyst is used in the Haber's process. Haber's process is the name for the process in which we manufacture ammonia. In Haber's process, nitrogen and hydrogen combine to form ammonia. Nitrogen comes from air and it is obtained by fractional distillation of liquid air. The hydrogen is obtained mainly from natural gas, which is methane, by cracking of oil. And iron in this process is used as a catalyst. So this is an application where iron is used as a catalyst in the manufacture of ammonia, and the process is called Haber's process. Students, another example in which iron is going to act as a catalyst is the reaction between persulfate ions and iodide ions. The reaction between persulfate ions, which are also called as peroxodisulfate ions, S2O8 with a charge of -2. When it is going to react with iodide ions in the solution, it is catalyzed by either iron 2 ions. Iron 2 ions means ferrous ions, Fe plus 2, or iron 3 ions, which is Fe plus 3. These two ions can also be written in this form. So S2O8 - 2, which are the persulfate ions, react with iodide ions in the solution to give sulfate ions and iodine. Now students, you can see that we are studying iron as a catalyst, but in this chemical equation, iron is nowhere because it is a catalyst, and this is an overall equation for this chemical reaction. Now students, in order to study the catalytic property of iron in this solution, let us look at the mechanism of this chemical reaction, which is going to take place in two steps. In the first step, the persulfate ion reacts with ferrous ions and convert into sulfate ions and ferric ions. Now students, how this redox reaction is taking place. Let us calculate the oxidation state of sulfur in persulfate ion, which comes out to be plus 7, and that of iron on the reactant side is plus 2. But after the chemical reaction, you can see in sulfate ions the oxidation state of sulfur is plus 6 and that of iron is plus 3. Means that iron is oxidized and the electron that is given off is taken up by sulfur. Therefore, the oxidation state is changed from plus 7 to plus 6 as it is getting reduced. So over here Fe plus 2 ions itself it is getting oxidized and acting as a reducing agent. Now students, in the second step what is going to happen? Iron 3 ions or ferric ions are going to react with iodide ions and give us Fe plus 2 again and an iodine molecule. Now students, look at the oxidation states. Fe plus 3 is getting converted into Fe plus 2 by the gain of electron, and 2I negative by the loss of electrons is converting into I2, and the oxidation state of I2 is 0. So it is decrease in the oxidation state. So now students, if you look at the overall equation, from these two steps, we can cancel out the ferric ions and we can cancel out the ferrous ions. And after that, we are left over with persulfate ions and iodide ions on the reactant side and sulfate ions and iodine molecule on the product side. So this is the overall reaction for this mechanism. As iron is acting as a catalyst, so it is regenerated in the second step. That is why we say that iron in this reaction is taking part but acting as a catalyst. If we are going to use iron 3 ions instead of iron 2 ions, if we are using iron 3 ions, then the second step is going to take place first, and after that the second step is going to take place. Now this is a good example of use of transition metal compounds as catalyst because of their ability to change oxidation states. Now you can see iron can change its oxidation state from ferrous to ferric and again from ferric to ferrous. Now students, let us study the reactions of iron ions in solutions. For example, in water. In water, the iron ions, they are present in the form of complexes like hexa aqua iron 2 complex, hexa aqua iron 2 complex, and since it is an ion, so we have to write ion in the end. And similarly, if iron is in plus 3 oxidation state, the complex is the hexa aqua iron 3 ions. So these are the two forms in which iron ions are present in water. Now students, let us study the reactions of iron ions when they are present in solution as complexes with bases like sodium hydroxide. Hydroxide ions, say if we are taking sodium hydroxide solution, they remove hydrogen ions from water ligands. These are the water ligands which are present in the iron 2 complex. And it is going to get converted into tetra aqua dihydroxo iron 2 complex. Now students, this is insoluble in water. This complex is going to be insoluble in water and green precipitates are going to form which are going to settle at the bottom. Now students, since from the sodium hydroxide OH negative ions are going to act as a base. And what does a base do? It is going to abstract protons. From where? From the water molecules which are present as ligands in the coordination complex. So students, depending upon the concentration, it is going to abstract proton from each water molecule. Now you can see over here, we are having 6 water molecules. When 2 hydroxyl ions are going to abstract proton from 2 water molecules, it is going to be converted into water. OH negative after gaining hydrogen is going to convert into H2O. Now students, since two hydroxyl ions is reacting with two water molecules, we are left over with 4 H2O, which are represented over here. But from the two with leftover water molecules, proton has been abstracted by this OH negative ions, and they are converted into OH negative now. You can see over here, after the removal of proton from two water molecules, we are left over with OH ions. So this is 2 for the two water molecules from which this base has abstracted protons. Now students, it is a neutral complex. It is called tetra aqua dihydroxo iron 2 complex, and it is a neutral complex. How? The oxidation state provided by water is 0 as it is a neutral ligand. OH carries -1 charge, so the overall charge is -2 for 2 OH, and the charge of iron is 2. So -2 is going to cancel out +2. So on the whole, this complex is neutral. Now students, whenever we have a neutral complex, mostly it is insoluble in water. That is why it is going to settle at the bottom. The color of this complex is green. So the precipitates are going to settle at the bottom. Now students, look at this diagram. This is the iron ions which are present in water as a complex, which is hexa aqua iron 2. Now solutions, when sodium hydroxide solution is added to it, it is converted into this complex. Now students, it is green in color, and on standing the precipitate darkens. Now why is it so? Because when it is going to be placed in this test tube, after a while the iron 2 ions will get converted into iron 3 ions, and the color change is going to indicate that iron is changing its oxidation state from +2 to +3. The precipitates darken and turns orange around the top. So this is going to indicate that iron on standing is going to change its oxidation state. But students, if we are having iron 3 ions in the solution, then the precipitates that are going to be obtained are reddish brown precipitates instead of green precipitates. So in case of iron 2, we obtain green precipitates, but for iron 3 ions, reddish brown precipitates are going to be formed. And the complex will be having the formula FeH2O3OH3. Now students, look at the chemical equation. This is hexa aqua iron 3 ions. When it is going to react with the base like sodium hydroxide, 3 hydroxyl ions are going to extract proton from 3 water molecules which are over here acting as a ligand, and will be converted into OH negative ions. So we will be left over with 3 H2O molecules which are acting as ligands. Now students, you can see that overall charge on this coordination sphere is 0. -3 for 3 hydroxyl ions, 0 for 3 water molecules, and +3 for this iron ion. +3 and -3 will cancel out each other, giving 0 oxidation state on the coordination sphere. And the 3 hydroxyl ions will be converted into 3 water molecules after taking up 3 protons from water molecules which were acting as ligands. Now students, look at the color change. This is iron 3 solution. When sodium hydroxide is added to the solution, it is going to convert into reddish brown precipitates of this neutral complex. Students, now we are going to discuss the reaction of these iron ions, means iron 2 ions and iron 3 ions, with ammonia solution. Now students, keep in mind that we are going to discuss ammonia as a base and going to discuss the reaction just like the hydroxyl ions. But ammonia can act both as a base and as a ligand. When it is going to act as a base, it is going to abstract the protons from water molecules which are attached in this complex as a ligand. And in the second case, ammonia can also act as ligands. Means it is going to donate the lone pair to the central metal atom and over here get into the coordination sphere as ligand. But in these cases, in the chemical reactions, we are simply going to study ammonia as a base, as it is going to remove the hydrogen ions from the aqua complexes and green precipitates of hydroxide ions are going to be formed. Now students, this is hexa aqua iron 2 complex which is present in the solution. Now when we are going to react this solution with ammonia, we are going to add ammonia solution in this test tube and we are going to obtain green precipitates for the same complex that we had obtained for hydroxyl ions. It is tetra-aquo dihydroxo iron 2 complex. The oxidation state is 0. Now students, these two ammonia molecules after abstracting 2 protons from 2 water molecules get converted into ammonium ions. And the 2 water molecules, they are converted into hydroxyl ions. Now this is the same chemical reaction as we have studied for hydroxyl ions with iron 2 ions. And you can see the color of the precipitates are also the same because the same complex is obtained. As ammonia is acting as a base and simply it is removing the protons from the ligands. Now students, look at the color change. These are the green precipitates of this complex. And upon standing, these green precipitates are going to get darkened and turn orange on the top, which is going to indicate that iron complex on standing is changing its oxidation state from +2 to +3. Now students, we are going to study the same reaction of iron ions with ammonia solution. But now in this case, we are taking iron 3 ions, means ferric ions. Now this is hexa aqua iron 3 complex which is yellow in color. Now students, when ammonia solution is added to this solution, it turns reddish brown because of this complex which is formed. What is going to happen? 3 ammonia molecules are going to abstract protons from 3 water molecules and get converted into 3 ammonium ions. The 3 water molecules from which the proton has been taken out is converted into 3 hydroxyl ions, and after that we are left over with 3 water molecules as ligands. The overall oxidation state on this complex is 0. Since it is a neutral complex, it is insoluble in water and it is going to settle at the bottom. The reddish brown precipitates are obtained. Students, this is all for today's lecture. We are going to study rest of the reactions of